Hello and welcome to this Edexcel Further Math Statistics 1 video on the central limit theorem. Video 1 looking at a recap of the normal distribution. And you should recall that the normal distribution is a continuous model defined by a population mean mu and a population variance sigma squared or standard deviation sigma. You should be familiar with this notation here, where x is a normally distributed random variable from a population with mean mu and variance sigma squared. Examples of normally distributed random variables might be heights of adult males, could be lengths of adult mice tails, or it could be the mass of sugar in a machine-filled bag of sugar. And normally distributed random variables will have the property that when plotted, a population will follow this bell-shaped curve, and within 3 standard deviations, virtually all 99.8% of all the population values will lie. Within 2 standard deviations, about 95% will lie, and within 1 standard deviation, 68%. And probabilities to do with the normal distribution can be found by finding areas under the normal curve. So if we take a particular population where heights are normally distributed with mean 150 centimeters and variance 100 centimeters squared, we know the mean and we know the standard deviation. What if we want to find the probability that a person selected at random from this population will have a height of more than 160 centimeters? So looking at a diagram of that, 160 is clearly the mean plus 1 standard deviation. So what we are wanting to find out is the area under the curve here, the area to the right of 1 standard deviation above the mean. And it's very simple to see by adding up the probabilities here that gives us 15.8% or 0.158. That was a very simple probability to find just looking at this standard curve, but what if we wanted to find the probability that a person was of height more than 152 centimeters, for example? So for the new Maths A-level exams, probabilities from the normal distribution should be found directly from a calculator. So if we look at a simple example going into the distribution statistics facility, if we choose the normal distribution, we need to select 2 normal cumulative distribution. We're not going to be using that one at all. We're going to be using the cumulative distribution, and if we want the probability of being greater than 118, our lower value is 118, and we then need to choose a suitable upper value, and that should be selected to be more than 4 or 5 standard deviations above the mean. So if we draw a quick sketch, this is the area that we are required to find, and that's clearly larger than a half. So putting in a suitable upper bound, and remember the standard deviation should be entered before the mean, the calculator will directly give us that probability as 0.871 to 3 decimal places. And it's worth checking that you are quite comfortable with doing that on your calculator. A second example here where we have to find the probability of being below a particular value. Again, we're going to select normal CD. If we need to be below a value, we need to choose a lower value that's 4 or more standard deviations below the mean. So I've chosen 0 there. The upper is 127, enter standard deviation and mean, and we obtain our probability directly, and it's always worthwhile just drawing a quick sketch to make sure that seems feasible. So we have 127 here, we want to be less than it, so this probability is going to be less than a half, and we have 0.297, correct 3 decimal places. You should have met the standardized normal distribution and realize that sometimes it's useful to transform a normal distribution x to a standardized normal distribution z with mean 0, standard deviation 1, and that relates to this diagram you've seen before where z is x minus the mean divided by the standard deviation. And you will find z-scores in the formula book in the table that gives you the percentage points for the normal distribution. And if you like to play around with GeoGebra a bit, it's good to set up some sliders and actually have a look at a real life scenario, so some values for x, and here we have mean and variance for x, and that's in pink, and then look at the equivalent z distribution, which is nice and symmetrically placed around 0, where we have mean 0, standard deviation 1, and you can see for each value you select the z-score that's relevant to that, and the probability, whether you use the z-score or whether you use the actual raw value, will be the same. Look at an example where a z-score is used rather than the actual x value that we started with. If we start with a value of 118, the z-score that corresponds to that is 118 minus the mean divided by the standard deviation, which is minus 1.133. And if we draw a little picture of that, the equivalent probability, if we look at z-scores rather than x values, would be to try and find the probability that z exceeds minus 1.133. And using standard deviation 1, mean 0, for our z-scores, you should find the probability of being greater than minus 1.133 gives exactly the same answer as we found before when we used x instead of z. And that concludes this video. In the next video we will look at the central limit theorem, an introduction to the central limit theorem.